are going to study something about data compression, where data compression is nothing but encoding the information in a file such a way that it takes up less space. So here we are going to study something about data compression techniques. There are 5 different techniques we have. First one is nothing but the redundancy reduction. Redundancy reduction. So what do you mean by redundancy reduction? You have already seen files such a way that we are going to compress it, like zip file, rar file, all those things. We call that files as redundancy reduced files, because whenever we are going to compress the files, what will happen is, suppose you have a 16-bit data, then you are going to compress it so that you have to get only 10 bits data, because the rest 6 bits data are of no use. So what you are going to do is that 16-bit data will be compressed into 10 bits data, so that your file will be reduced and you will get only the useful data in your file. So for example, it is zip file, rar file, all those things. So that is the first redundancy reduction first techniques in the data compression. Second technique is nothing but run length encoding. Run length encoding. So what do you mean by run length encoding? So when you are using run length encoding, you are going to use a special algorithm for this. So let me tell you something about run length encoding algorithm. So it is having 3 steps. First step is you are going to use a special run length indicator. We are calling it as run length encoder. It is going to be used, and next you are going to use the pixel values which are repeating, and the third one you are going to use is number of times the value is repeated. Number of times the value is repeated. So let us take an example. So you suppose you have some numbers with the 22, 23 and so many 24. Then you have 25, 26, so many number of 26, like this. Now how we are going to convert it using run length and encoding algorithm? So here what you are going to use is this is not repeating, so I am going to write it as it is. Then you have 23 which is not repeating, we are going to write it as it is. Then 24, it repeats 5 times. So what I am going to use is, I am going to use a special run length encoding. Say it can be any character, so I am going to use XX. So this is a special run length encoder, and then you are going to write the pixel value which is repeating. So 24 is the pixel value which is repeating, and then the number of times that value is repeated. So you have 5 times it is repeated, so I am going to write it as 5. Then you have 25, then you have 26, so which is repeating. Once again I'll write it as XX 26. Then how many times it is repeating? 5 times, then 27. Now this is the reduced format of the previous one. So this type of suppressing the repeated sequences, we are calling it as run length encoding. We are calling it as run length encoding. So this is the second algorithm you have, second type of data compression technique. Next type is Morse code, or we can also call it as variable length code. So in variable length code, it is a one more type of, we can call one more type of redundancy reduction. So an example for this is Huffman coding. Huffman coding is an example for Morse code. In Huffman coding, what you will be having is, you will be having the values and the frequency. Values and the frequency. Value is nothing but the data whichever you are having, which needs to be compressed, and frequency is nothing but how many times the data has been repeated. Sometimes the same data will be repeated more than once, so we are going to write how many times that data has been repeated. That is nothing but the frequency. So let us see an example for Huffman coding. So I'll take a table of value and frequency. Say A, B, C, D, E and F are the values, and frequency is 5, 25, 7, 15, 4 and 12. Now I want to construct a Huffman tree out of this table. So the first step I want to do is sort. That means you need to arrange this table in an ascending order of frequencies. So here I need to write value and frequency table again. So ascending order of frequency means first one is nothing but E. So E and frequency is 4. Then you have A and frequency is 5. Then you have C and 7. Then you have F and 12, D 15, B 25. So now you got the ascending order of frequency. This is the first step you have. Now using this, what I am going to do is, I'll take the least 2 frequency values and I will arrange it as a Huffman tree. Say I am going to take E, which is having frequency 4, and I'll take A, which is having frequency 5. Now I will make a tree out of this. So I will add this frequency value 4 and 5. I'll get 9. So this is the next step you have. Now according to this, how we can write the table. Now we are going to get a value of 9. So instead of these two, I will have the value 9. So 9 is bigger than 7. So I need to write the table as C7, then EA, which is 9, then F12 and rest everything. So what I am going to get now, C7 value and frequency, C7 EA, which is 9, F12, D15, B25. Now repeat this step 2 again. So what you are going to get, 7 and 9 you are going to club. That is, we already have done like 4, 5, E and A, you got it as 9. Now again you have C in the left hand side. So I will add C7 to this 9. So what I will get, 7 plus 9, you are going to get it as 16. So this is the next particular tree. What will be the values now? Now you got 16. These two value we got it as 16, which is bigger than 12 and 15. So I will get F12, D15. Then the next one, CEA as 16 and B as 25. This will be our table. Now let us go to the next step. You need to repeat the same step again. So what you are going to get, the table as F12, D15, CEA as 16, B as 25. Now we have these two to add up, so this will act as separated tree. So F12 D15, you will get 27 as the output, and here you will be having the other tree also. What was the other tree you have? You have the other tree as 16, under which you have C17, and 9, under which you have E4 and A5. Now what you are going to do is you are going to write the table again. So what you will get now, you will get FD27, then CEA 16, B 25. These are the values. We need to rearrange it. FD will come to the last position. So in the next step, you are going to add CEA and B. You are going to get 16 plus 25, that is 41 for the next step. So what you are going to get the tree as, you had E4, A5, and you got 9, C7, you got 16. Now you have B25 with you, so you are going to get it as 41. And here you have F12 and D15, you got it as 27. Now the last step is you are going to add these two. You are going to get 68 as the top root value. So this is the Huffman tree you have built. So if you consider this, you have these complete set of tree which is having left subtree and right subtree. So what I am going to do is, left node I am going to value as 0 and right node I am going to value as 1. So left branch we are going to name it as 0, right branch as 1, 0 1 0 1 0 1, and here 0 1. This is a tree we are going to construct. Now using this Huffman code, using this we are going to write the Huffman code. Now if you see this E, if you want to write the Huffman code for E, you need to start from the root. So it will travel over here 1, you will get 1, then it will come here 0, then it will come here 1, and it will come here 0. So for E, the Huffman code is 1010. In the same way for A, Huffman code is 1011. For F, Huffman code is 00. Like that we can write the Huffman code. And if you want to encode, say we will write each code now. A 1011, B 11, C 100, D 01, and E 1010, F is 00. Now if you consider this, if I want to write a Huffman code for BEF, how can I write? If suppose this is my string, then I can write it as 11 1010 and 00. This is for B, this is for E, and this is for F. So this will be the Huffman code after the encoding. Then we have the fourth technique. We can call it as irreversible compression technique. Irreversible compression technique. So in irreversible compression technique, what will happen is, suppose you have an image size with say 400 into 400 by 400 pixel image you have, and suppose you are going to compress it, you are going to reduce the size of this to 100 cross 100. What will happen? The size will be reduced. That means you are going to remove some pixels from it, and you cannot, if you have removed some pixel, you cannot come back to this image. Once again, if you make it big with the 400 into 400, you will not get the quality image. You will not get the quality image. So this type of compression technique, we are calling it as irreversible compression technique, where you cannot get the original data again. You cannot preserve the original data once again. And one more is compression in Unix. Compression in Unix. So in Unix, they are going to use some of the compression methods such as pack and unpack function, as we have already discussed this in module 1, pack and unpack function. Then they are also using the functions such as compress and uncompress functions. So these are the predefined functions they have in Unix. So this is about the data compression, different types of data compression technique.